Good afternoon, Rich Nass, Embedded Computing Design here in Nuremberg at Embedded World. I am in the Adacore booth, but I'm talking to Jonathan Pallant, and he is with Ferrous Systems, actually a senior embedded engineer. How you doing, Jonathan?
Great. It's been a really busy show.
It has been a busy show, and that's a really good thing. What I wanted to talk to you about, though, is a topic that just keeps coming up over and over and over again, embedded Rust. Well, actually, Rust in general. So the first question is, what's the difference between embedded Rust and Rust?
When people are developing with Rust, they're normally targeting Windows, Mac, Linux. They're used to working with an operating system, so they're expecting APIs for handling multiple threads, working with a file system, and that kind of thing. But as with C and the difference between C and embedded C, we can also use Rust on much smaller platforms, microcontrollers and things like that. And when we do that, we take away what's called Rust standard library, and we work with the libcore, or the core library. All of the operating system specific functions go away, and we're left with a much thinner layer that we can use on bare metal systems. Okay. And that's what we mean by embedded Rust.
And why should embedded developers be excited about embedded Rust now?
One of the things that excites me about embedded Rust is we get all of the powerful features of the compiler in terms of memory management and checking the lifetimes of objects. So we can have these issues in C where I allocate some memory and I've got a pointer, I free the memory, but I still have the pointer, and Rust solves all these problems at compile time. And it's great that we can do that on big systems, Windows, Mac, and Linux, but it's amazing we can still do that on microcontrollers with small amounts of memory.
So keep going one step further. What platforms are actually supported?
We have great support for ARM, Cortex-M, and Cortex-R. We also have support for PowerPC, MIPS. Infineon recently announced support for the Aurix Tricore. So yeah, really great spread of embedded platforms.
Okay, now take that one step further. Where is embedded Rust headed?
Well, one of the things we're really excited about at Ferrous Systems is our joint project with Adacore, where we've produced a qualified Rust toolchain for safety certified systems. So all of the great benefits people are enjoying about Rust, we say, well, why not bring that to the safety critical community? Why do they have to stick with C? So now there's this tool chain available, working with our friends at Adacore. And yeah, we're really excited to see what people build in, especially in the automotive space with this new tool chain, Ferrocing.
Very good. Thank you, Jonathan.
Been a pleasure. Thank you.
And now I'm speaking with Yannick Moy, who leads the static analysis team at Adacore. Why would people want to move to these new languages when what they're doing seems to be working pretty good anyway?
So what they do doesn't seem to work that well when it comes to safety and security, and people have to meet harder objectives these days because the threats are more palatable, and security agencies and the legislation is changing, and people want a language that really helps them to achieve these goals in terms of safety and security. So that's why they want a language that really helps, that doesn't get in the way, and that is full of traps, which can be the case for C and C++. No matter how many tools you put on top to find bugs through fuzzing, through static analysis, the language doesn't help as much as it could.
Why Rust, of all the choices that are out there?
So Adacore got interested in Rust because we believe for a long time, so with our support of Ada and the Spark subset of Ada for formal verification, that language is one of the primary tools through which you achieve this higher level of safety and security. And Rust is one of these new languages that has the same goals as Ada and which gets a lot of traction. And so we're interested in making Rust successful in the domains with which we're acquainted with, which are all the safe and secure software domains.
Very good. Thank you, Yannick.